All right, let's jump right into a mystery that I bet you've experienced. You're at a concert, a big game, maybe just a packed city street, and suddenly your phone's internet connection just dies. It's so frustrating, right? Well, today we're going to pull back the curtain and see exactly why that happens and explore the incredible, invisible tech that's working to fix it.
I mean, this is the big question, isn't it? You've got full bars of service, but absolutely nothing will load. It feels like your phone is just giving up on you. But the truth is, the problem isn't your phone. It's a massive, unseen traffic jam happening in the airwaves all around us. So, before we can talk about the solutions, we've really got to understand the problem. And that digital traffic jam idea is the perfect way to think about it. It's not just about how many people are using their phones, but where they are and when. That creates some serious bottlenecks.
Now get a load of this number. According to a report from Ericsson, the demand for data in a busy city center can be 1,000 times higher than in a quiet rural spot. 1,000 times. I mean, how is a single network supposed to handle that kind of massive swing? And this chart really drives the point home. The problem is also growing unevenly. Just look at this data from Western Europe. In dense cities, traffic shot up by as much as 80% in just 1 year, but out in the country, less than 10%. So the network has to constantly adapt to where the people are.
And just to make it even more complicated, different places have totally different rush hours for data. In the city, the peak is right in the middle of the workday. Makes sense. But in rural areas, it's the evening when everybody gets home and gets online. Trying to manage this is like trying to coordinate rush hour for a dozen different cities, all at the same time.
Okay, so faced with this absolute chaos, how do our networks not just completely collapse? Well, they have some really clever first responders, a set of tools designed to manage this digital traffic jam in real time. First up, and probably the most important, is something called load balancing. The best way to think of this is like a traffic cop for the network. When one cell tower starts getting totally swamped with users, the system is smart enough to say, whoa, too much here, and automatically starts rerouting some of that traffic over to a nearby tower that has some room to spare. It's a nonstop, automatic shuffle to make sure no single part of the network gets overwhelmed. And this is a perfect way to visualize it. The network is constantly trying to keep these scales perfectly balanced. On one side, you've got all of us, on our phones, demanding data. On the other, you've got the network's actual resources. It is a really delicate balancing act that's happening every single second of the day without us ever noticing.
Now, another awesome tool they use is called carrier aggregation. So if load balancing is about redirecting traffic to different roads, carrier aggregation is like the network instantly building more lanes on the highway just for you.
It's pretty cool how it works. Your phone is smart enough to see several different radio frequencies, or carriers, all at once, and the network can then give your phone permission to use them all at the same time, combining them into one super wide data highway. Honestly, this is a huge reason why things like 5G can feel so incredibly fast.
Okay, so load balancing and carrier aggregation are fantastic, but they're mostly reactive. They fix problems as they happen. This next part, this is the leap into the future. This is where the network starts to think for itself. I want you to meet the self-organizing network, or SUN for short. You can basically think of this as an AI for the entire mobile grid. Its whole job is to automate all the ridiculously complex tasks of setting up, fine-tuning, and even repairing the network, all without a human having to step in. A SUN basically has 3 superpowers. First is self-configuration. That means you can put up a new cell tower and it just plugs itself in. It automatically adjusts to work perfectly with all the other towers around it. Then there's self-optimization, where it's constantly tweaking itself to avoid traffic jams. But the most mind-blowing one, that's self-healing.
Yeah, let's zoom in on that last one, because this is where it starts to feel a little like science fiction. What actually happens when a crucial piece of the network, like a whole cell tower, just goes dark?
So in the old days, a tower failure was a big deal. It would create a total dead zone, a coverage gap, and everyone in that area would lose their connection. Calls would drop, data would stop, and it would stay that way until a crew of engineers could get out there and fix it. But with a self-organizing network, something amazing happens. The system instantly detects that failure. The towers nearby then start talking to each other, and they automatically boost their power and physically change the angle of their antennas to fill in that gap. For you, on the ground, you notice nothing. The service just continues. The network literally heals itself. Okay, this tech is just incredibly cool, right? But so what? Why does this really matter? Well, the stakes here are actually way higher than just making sure your videos don't buffer.
I want you to imagine a real crisis, a natural disaster, a major public emergency. A smart network like this can automatically sense what's happening and intelligently give priority to first responders. It makes sure that firefighters, paramedics, and police have a crystal clear, reliable connection right when everyone else is trying to use their phone. It can be an actual lifeline.
And you don't have to take my word for it. This quote from a research paper really nails it. It's basically saying that as our networks get more and more complex with 5G and beyond, this kind of automation isn't just a nice feature, it's absolutely necessary to keep the whole thing running. And believe it or not, it doesn't stop there. The next step is something called a cognitive SON. Using some heavy-duty AI and machine learning, the network won't just react to problems. It's going to start predicting them. It'll learn our usage patterns and know that a tower is about to get congested in an hour, and it'll start rerouting traffic before we ever notice a slowdown.
Which really just leaves us with this one big, fascinating question to think about. We've watched our networks go from being manually managed to self-healing, and now they're on the verge of becoming predictive. So as this global grid we all depend on becomes truly intelligent, truly autonomous, what else will it make possible?